Alright, you guys. So most of you were in class today. We were able to go over some of the front side. Every period was a little bit different. So what I'm going to do is I'm going to go through the entire front side. If you already saw some of this, you can watch it. You can fast forward through it and just stop and pause it based on what you saw and what you need to review. The back side, we didn't. In no period did we get to. We're going to talk about some of these problems in this video because you're actually able to do some of these problems even though we didn't do them in class. And I asked you guys over the weekend to try these problems. These problems are all possible. All they're asked to do is to simplify the following expressions using what we talked about with factoring yesterday, foiling, powers and exponents, and then in this video we talk about some trig identities that would help you reduce some of these expressions. So I'm going to start from the top. Like I said, if you already saw some of this, just bear with me or fast forward the video. So the two identities that we talked about, the first one was the Pythagorean identity. And the Pythagorean identity, excuse my horrible manicure, is the relationship between sine and cosine. So sine squared t plus cosine squared t equals 1 for every value of t. What is t? Just a value, it's a number, but of course if we're taking the sine and the cosine of it, it has to be an angle. So for example, if t was 3, it would mean 3 radians. T of an angle measure in radians for every value of t. Okay, so that's our first identity. Our other identity is our relationship of tangent to sine and cosine. So we know that the tangent of any angle, again we'll use t to represent our angle, is just sine of that same angle divided by cosine of that same angle. And again, a t is just a common variable that we use to represent some angle measure in radians. So it says in the following example, use the above identities, the definitions of sine and cosine, so just basically SOHCAHTOA, our knowledge of angles in standard position, so those angles that start on the positive x-axis and rotate if they're positive in the counterclockwise direction or negative in the counterclockwise direction, to find what the question asks you to find. So in this first example, it says determine, this should be if, it's possible for a number t to satisfy, which means make it true, the given condition. So basically they're saying sine of t equals -1 and cosine of t equals 1. Because they're asking us to see if this is possible, so basically is there a radian measure where if we take the sine of it we'd get -1 and if we took the cosine of it we'd get +1. So basically if sine of t equals -1, does cosine of t equal +1? Or can sine of t equal -1 and cosine of t equal +1 for the same value of t? So to check that, we have to ask ourselves, well, if it does, then it will satisfy the Pythagorean identity. So in this case, we'll use our Pythagorean identity to test to see if it's true. So does sine squared of t plus cosine squared of t equal 1 if we plug in these values? So if sine equals -1, can cosine equal +1? Well, if it can, then this identity will hold true. So in this case, it'll end up being a true statement. 1 squared is 1, or -1 squared is 1, +1 squared is 1, and does it equal +1? No. We see that the side equals 2, so 2 does not equal 1. Therefore, there's not a value of t that we can plug in here and here and have both expressions be true. So in this case, there's no value of t that makes this true, so no value of t will satisfy this condition. Okay. Because when we plugged in those values for sine and cosine into our Pythagorean identity, it didn't maintain the identity. It didn't make this identity true. So if we try the same thing with this example, they gave us a value of sine, they gave us a value of cosine, and said, if sine of t equals 1 over root 2, can cosine of t equal -1 over root 2? So to test it, again, we'll just plug it into the Pythagorean identity, because the Pythagorean identity is an identity that will always hold true for every value of t. So in this case, we're saying that sine is 1 over root 2, and in the Pythagorean identity we have to square sine, and cosine is negative 1 over root 2, but in the Pythagorean identity we're squaring cosine. Basically we're asking, does this or will this still equal 1? So anytime we square root or square a fraction, we multiply top with top, bottom with bottom, so it's going to be 1 times 1 is 1, square root of 2 times square root of 2 is 2. Over here, negative 1 times negative 1 is positive 1, square root of 2 times square root of 2 is just 2. Does this equal 1? Absolutely. 1 half plus 1 half is 1. 1 equals 1. So in this case, we would say yes, there is a number t, or there is an angle, there is a number, there is a value for t that will satisfy this condition. Okay. How could we find that value if you were curious? Well, we could basically just solve this equation. If we take the arc sine of that value, so in this case if I want my angle in radians, I can change my calculator to radians. So if I took the arc sine of 1 divided by square root of 2, even though it's not rationalized, our calculator will accept it. This, if we traveled 0.78539 radians, we would get that value. Now just to test, let me show you that if we took the cosine of this many radians, so this is our value of t, so if I took the cosine of my answer, so I plugged in that number, that's our number t, we should get negative 1 over root 2. Well, you guys don't know what negative 1 over root 2 is, either do I, so let's plug this in and actually figure out what's negative 1 divided by root 2. If this all works out, it should equal 0.707. Sure enough, obviously it's a negative value, so the cosine of that angle, it always gives us the positive value, but in this case where sine's positive and cosine's negative, sine's positive, so sine is our y-coordinate, cosine's negative, so here we know that would only occur in this quadrant. So what the calculator is actually finding is the equivalent angle. The calculator only gives you the angles, why it gave us the positive one, it will find the positive one in quadrant 1. But in this case, basically that we still know that cosine could equal that same value. So if that was way over your head, if that was kind of weird, hang with me. But basically, by plugging into the Pythagorean identity, we know that this condition is true because it made a Pythagorean identity true. All right, to move on to the next example, it says, given the following information, find sine of t and tangent of t. So the information that they give us here is that they tell us what the ratio of cosine is, and they tell us that t is between pi over 2 and pi. So I'm going to do this 2 different ways. This video is getting kind of long already, I apologize. I'm going to do it once with the algebra, and I'm going to do it once with a picture. So in this case, I'm going to do it first with the algebra. So in this case, if we have cosine and we want to know sine, we just need to use the Pythagorean identity. So in this case, we know that sine squared plus cosine squared equals 1. So we don't know what sine is, but we know cosine is negative 3 over root 10. I need to square it because cosine squared. And here we can just solve this equation using algebra. So if we square this fraction, negative 3 times negative 3 is 9. Square root of 10 times square root of 10 is 10. Subtract 9/10 from both sides. Again, if you subtract 9/10, it's like changing this into 10 over 10, which is a whole. So 10 over 10 minus 9 over 10 gives us 1 over 10. Take the square root. So sine of t will equal square root of 1 is 1, square root of 10 is square root of 10, but we have to rationalize it, so we get root 10 over 10. I always want our answers rationalized. Now they also asked us to find the tangent of t, but the good news is, guys, tangent can just be looked at as sine over cosine. So in this case, tangent of t It's just going to equal our sine of t over cosine of t. So we have sine was root 10 over 10. Cosine was the value that they gave us, negative 3 over root 10. With division with fractions, you just have to flip the second or the bottom and multiply. So in this case, you would take root 10 over 10 and multiply it by the reciprocal of the bottom. So in this case, that would be, so root 10 over 10 times the reciprocal of this expression, which is root 10 over 3. Now we can just multiply straight across. Root 10 times root 10 is 10. I lost a negative. 10 times negative 3 is negative 30, which reduces to negative 1/3. So there's tan of t. Okay. So there's the algebra of how we could find the sine and the tangent if they only gave us cosine. Now that seems like a lot of work, and you have to be good with your algebra. You have to know about powers and subtraction with fractions and square roots and whatnot and rationalizing. There's a lot of information in here, or a lot of algebraic concepts and arithmetic. But you guys are all capable of it. Another way to do this is to simply draw a picture of this scenario, which is what I'm going to do here on this paper now. So in this case, to draw a picture, we know t is a radian measure, so it's a distance that we travel around a circle. Right. So in standard position. And they tell us that t is somewhere between pi over 2 and pi. So if we look and we know about radians, pi over 2 is 90 degrees, or equivalent. So in standard position, if we looked at this as 0 radians, this is pi over 2, this is pi. So t is going to end somewhere in quadrant 2. Now, the nice thing when you're doing these problems, if you're just trying to find ratios, you don't actually have to draw your picture to scale. So we don't have to be able to figure out where in this quadrant cosine is equal to negative root 3 over 2. In fact, our picture, like I said, doesn't have to be accurate just to find ratios. So in this case, I always like to just draw my angle. So if I drew my angle in t, just have it end anywhere in this quadrant. So it's going to end somewhere. Sketch in your triangle. Keep in mind that our angle, t radians, is from here to here. If we looked at it in terms of theta, degrees, it's from here to here. But we always use our reference angle right in here when we're trying to find sine, cosine of tangent of any angle that ends outside of quadrant 1. So cosine, they gave us a ratio. It was negative root 3 over 10. Cosine's adjacent over hypotenuse. So one scenario is that your adjacent side is negative 3. So let's say this distance from here to here is negative 3. And your hypotenuse is square root of 10. Okay. But it doesn't have to be, but since it's a ratio and it's the only ratio they gave us, we could actually create that exact scenario where the adjacent side is negative 3, the hypotenuse is 10. In this case, we can find our opposite side of our triangle by using a squared plus b squared equals c squared. So it doesn't matter which side's a or b, it has to be one of the legs though. So I'm going to make a negative 3. B is this side here. And c always does have to be our hypotenuse. So in this case, negative 3 squared is 9. Negative 10 squared is 10. Subtract 9 from both sides. So we get that b is positive or negative 1, because when you take a square root, you get plus or minus. But in this case, we know it's in quadrant 2, so it has to be a positive 1. So the nice thing is, once you have your picture drawn, you can find sine and tangent by just knowing that sine is opposite over hypotenuse. So sine of t, it's going to be opposite over hypotenuse, so 1 over root 10, which rationalizes to root 10 over 10. And tangent of t, TOA, is opposite over adjacent, so it's 1 over negative 3, which was the same thing as just negative 1/3. And that is the exact same 2 answers that we got with the algebra. So I know a lot of you are going to like the pictures, which I personally like as well, but just know that there's an algebraic way to do it as, in addition to the picture. So go ahead and try this one on your own. We'll double check your answer in class. Make sure you guys got this right values for sine and tangent. I challenge you guys to try drawing it with a picture. I challenge you to try to do the algebra to see if you get the same answer so you know how to do it 2 different ways. In addition, you should be able to simplify these expressions by what we've done yesterday with multiplying and factoring. I don't think there's much factoring going on with these problems. In fact, no factoring, but definitely using your identities, using the distributive property. We're going to go through these on Monday, but if you want to give it a shot and kind of get ahead, you'll notice that this problem, they gave you sine of t and they told you what quadrant t ended in. From that information alone, you can definitely find cosine and tangent, if not some of these other expressions, if you want to get ahead and give it a shot. So just note that if you have negative t, that's just traveling the same distance here, but traveling in the opposite direction. So play around with that. But we will go over this on Monday. So have a great weekend, you guys. Feel free to come in the morning, come in at lunch, come in after school with questions, or you want to check any answers on worksheets or even problems for book problems. Remember, all the odd problems are in the back. I know sometimes it feels like we're cramming, but really we're just reviewing chapter 2 for the final exam. Of course, we're going to take a test over this as well. So if you can get this stuff down, you'll just have some chapter 1 and a little bit of chapter 0 to review for the final exam. The focus of the final exam is chapter 1 and chapter 2, since those are the 2 trig chapters in this semester. So anyhow, have a great weekend. Email me with questions. Work on Khan Academy. I think you have plenty to work on. Just look at it in a positive light. Say, hey, this is just practice. Practice for the test, practice for the final exam. And I'll see you guys on Monday.